we're going to talk quickly about how to solve an equation graphically rather than algebraically. We've solved equations algebraically before. This is a very simple equation. X plus 5 is equal to 11. Hopefully everybody can look at that and realize that the answer is just x equals 6. We already know that the answer is 6. We're going to talk about how we can find that answer 6 on the graph. And this will be kind of a precursor to solving quadratic equations graphically, to show you that you actually can solve them both the same way, even though a linear equation results in a line, whereas a quadratic equation will result in a parabola. Okay, the very first thing you need to do is put it in the form of ax plus b is equal to 0. Right? Basically what that means is you want to take all the terms and get them on one side, and that would leave the other side be 0. So in this particular case you'd have x minus 6 is equal to 0. And that would be if you took all the terms and moved them to the left, subtract 11 from both sides. Okay? You could also move them all to the right, in which case you would end up with 0 is equal to negative x plus 6, or you could have 6 minus x. Once you've done that, then what we're going to do is we're going to put y in place of the 0. And so you can see all I did was take out the 0 and put in a y. And if I had this one, I would have y equals negative x plus 6. And then all that's left is to graph the equation y equals ax plus b, which in this case is just y equals x minus 6 or y equals negative x plus 6. Let's put 4's in here. And if you were to graph that, the first one you'd have a y-intercept of negative 6 and a slope of 1. Your line would be going up. On the second one you'd have a y-intercept of 6, a slope of negative 1. Your line would be going down. The solution to the original equation is just the x-intercept. That's what the solution is. So there's always the x-intercept. And in this case, the x-intercept is equal to 0, and that is actually the solution to the equation, which we just had up above at the top there where we did it algebraically. It's not meant to make things go faster. Obviously, that's a lot more work to get that x equals 6. But the point is to try and show you that the solution is the x-intercept. If you think about what we did here, we put 0 where y was. Anytime you put 0 in where y is, you're finding the x-intercept. And so that's why it ends up being the x-intercept in the solution. Now I'm going to go through one example. We'll show you how you can solve 3x minus 12 equals x plus 9 graphically. We could solve it algebraically if we wanted to. And if we were to go through there and solve it algebraically, we would basically you'd get all the x's on one side and everything else on the other. If you were to do that, you would end up with 2x on the left, and on the right you would get 21. And you could solve it, and you can see that the answer is going to be 10.5. So that's what the answer has to be. We know that by doing it algebraically. Now if I go through and do it graphically, what should happen is I should end up with an equation that if I graph it, crosses the x-axis at 10.5. Now I'm going to talk about how you can do it two ways. It doesn't make any difference. You can either move everything to the left or you can move everything to the right. So if you move everything to the left, you get what's in blue. And if you move everything to the right, you get what's in pink. So the very first thing you'd end up with on the left is 2x minus 21 equals 0. Subtract x and subtract 9 from both sides. If you were going to the right, it would just be kind of the opposite. 0 is equal to negative 2x plus 21. The next thing you do is put y in for 0. So if we do that in both cases, the left side's now 2x minus 21 is equal to y, and the right side is y is equal to negative 2x plus 21. And then all you would have to do is graph those two equations. So you would graph 2x minus 21 and find where the x-intercept is, you would graph negative 2x plus 21, find out where the x-intercept is. You can see that on one of them your y-intercept is negative and your slope is positive, and on the other one your y-intercept is positive and your slope is negative. And so they're going to cross at the same spot. And so if we go through and graph quickly what these two things are, y equals 2x minus 21, and then we'll put the other one as well. So in this case our slope is negative, our slope is 2, which is 2 over 1. Our y-intercept is negative 21. And notice it does say that the intervals are 2. So the intervals are 2, so each line represents 2 here. So if we go down to negative 21, 2, 4, 6, 8, 10, that's negative 20. And there's negative 21. And then our slope is 2. So we'll go up 2 and write 1. Up 2 and, oops, didn't do that quite right. Right, if our intervals are 1, so let's do up 4. Up 4 and write 2. Up 4 and write 2. 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 And we could keep on going. And we'll draw a line here. Now, other than the fact that we're a little off due to doing it on the computer here, the x-intercept is right there. Get this right one of these days. Hey, the x-intercept is right there, and that's 2, 4, 6, 8, 10. That particular point right there is 10 and a half. And then that should be our answer. And if we go and graph the other one, remember our other possibility was negative 2x plus 21. Here the slope is negative 2, and the y-intercept is positive 21. So now we would come up 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 1. Be right here. And then our slope is negative 2, so I'm going to go down 4 and right 2. Down 2 and down 4, right 2, down 4, right 2. And so now we draw our line here. And you can see that the line crosses at the same spot. And so we've done it graphically. It doesn't matter whether you take everything to the left in the blue or to the right in the pink. Okay? Our answer, our x-intercept, is the same thing, because one line goes down, one line goes up. Okay, they intersect at 10.5 on the x-axis, and 10.5 just so happens to be the answer we found here in green. And again, this is a precursor to what we're going to be doing. Eventually, we're not going to be just always doing lines. We will do quadratic equations, and the solution for a quadratic equation can also be found on the x-intercept, just like it is here for a linear equation.